Coordinate geometry. Exercise 7.1, problem number 6 of 1. Name the type of quadrilateral formed, if any, by the following points and give reasons for your answer. The points are -1, -2, 1, 0, -1, 2, and -3, 0. Here they have given 4 different points. We need to find out whether these 4 points form a quadrilateral or not. If quadrilateral is formed, then we have to name what is the type of the quadrilateral. And also we need to specify our answer with proper reasons. First, let us assume that these 4 points represent the vertices of the quadrilateral. Let A is equal to -1, minus of 2, B is equal to 1, 0, C is equal to -1, 2, and D is equal to -3, 0 represent vertices of a quadrilateral. Vertices of a quadrilateral. So what is a quadrilateral? A quadrilateral is a four-sided closed figure. In order to name the quadrilateral, we need to find the distance or the length of each sides of the quadrilateral and also the length of the diagonal. Once we find the sides of the quadrilateral and also the diagonal, we can name the quadrilateral. For finding the length of each side of the quadrilateral, the formula we use is A is equal to root of x2 minus of x1 the whole square plus y2 minus of y1 the whole square units. First, let us find the distance of AB. Distance of AB. For finding the distance of AB, we need to consider the point A and B. Point A is -1, -2 and the point B is 1, 0. Here we assume A to be x1, y1 and B to be x2, y2. So therefore, distance is equal to what? Root of x2 minus of x1, that is 1 plus 1 the whole square plus y2 minus of y1, that is 0 plus 2 the whole square, which is equal to root of 1 plus 1 is 2, 2 the whole square is 4. So 4 plus 0 plus 2 is 2, 2 the whole square is 4. So that is equal to 4 plus 4 is 8, root of 8. So that is equal to 2 root 2 units. Similarly, we need to find the distance of BC. Distance of BC. Distance of BC. For this, we need to consider the point B and C. B is 1, 0 and the point C is -1, 2. Let us take this point as x1, y1 and x2, y2. Applying the distance formula, we will be getting D is equal to root of x2 minus of x1, that is minus of 1 minus of 1 the whole square plus y2 minus of y1, 2 minus of 0 the whole square. So that is equal to -2 the whole square gives 4. So 4 plus 2 square is 4. So that is equal to root of 8, which is equal to 2 root 2 units. Thirdly, we need to find the distance of CD. For this, we need to take the point C and D. The point C is -1, 2 and the point D is -3, 0. Let us take this point as x1, y1 and x2, y2. So therefore, distance D is equal to what? Root of x2 minus of x1, that is minus of 3 plus 1 the whole square plus 0 minus of 2 the whole square. So that is equal to root of -3 plus 1 gives minus of 2. Minus of 2 the whole square is 4. So 4 plus -2 the whole square is 4. So that is equal to root of 8, which gives 2 root 2 units. Next, we need to find the distance of AD. For this, we need to take the point A and D. A is minus 1 comma minus of 2 and the point D is minus 3 comma 0. Let us take this point as x1 comma y1 and x2 comma y2. So therefore, distance D is equal to what? Distance D is equal to root of minus 3 plus 1. So minus 3 plus 1 the whole square plus 0 plus 2. 0 plus 2 the whole square. So that is equal to minus 3 plus 1 gives minus of 2. Minus of 2 the whole square is 4. So 4 plus 2 square is 4. So that is equal to 4 plus 4 is 8. Root of 8. So that is equal to 2 root 2 units. Now we have found the sides of the quadrilateral. We should not end with this. We should also find the length of the diagonal. 5. Length of the diagonal. Here the diagonal is AC and BD. Therefore, distance of AC. Point A is minus 1 comma minus 2 and point C is minus 1 comma 2. So therefore, D is equal to what? D is equal to root of minus 1 plus 1. So minus 1 plus 1 the whole square plus 2 plus 2. So 2 plus 2 the whole square. So that is equal to minus 1 plus 1 gives 0. 2 plus 2, 4. 4 square is 16. Root of 16 gives 4 units. Similarly, we need to find the other diagonal length. That is distance of BD. For this, we need to consider 2 points B and D. B is 1 comma 0 and D is minus 3 comma 0. So therefore, D is equal to root of x2 minus of x1. That is minus of 3 minus of 1 the whole square plus 0 minus of 0. 0 minus of 0 the whole square. So that is equal to minus 4 the whole square. We will be getting 16. 16 plus 0. So that is equal to root of 16, which gives 4 unit. Here, if we see, distance of AB is equal to distance of BC is equal to distance of CD, that is equal to distance of AD. Since AB is equal to BC is equal to CD is equal to AD. Since the four sides of the quadrilateral are equal and also the diagonal length, also the diagonal AC is equal to BD. AC is equal to BD. We can say that the given points form vertices of a square. Form vertices of a square. Hence, the quadrilateral formed here is square. Exercise 7.1, problem number 6 of 2. Here, they have given 4 different points. We need to check whether these 4 points form a quadrilateral. If so, what is the name of the quadrilateral? Let us assume these 4 points as the vertices of the quadrilateral. So, let A is equal to minus 3 comma 5, B is equal to 3 comma 1, C is equal to 0 comma 3 and D is equal to minus 1 comma minus 4 represent vertices of the quadrilateral. Vertices of the quadrilateral ABCD. Quadrilateral A, B, C. So to check what is the type of quadrilateral formed, we need to find the distances of AB, BC, CD and DA. So for calculating the distance, the formula we use is A is equal to root of x2 minus of x1 the whole square plus y2 minus of y1 the whole square units. First, let us calculate the distance of AB. Distance of AB. So for calculating the distance of AB, we need to consider the point A and B. That is, A is minus 3, 5 and the point B is 3, 1. Let us consider A as x1, y1 and B as x2, y2. So therefore, distance D is equal to what? So therefore, distance D is equal to root of x2 minus of x1. That is 3 plus 3 the whole square plus y2 minus of y1. 1 minus of 5 the whole square. So that is equal to root of 3 plus 3 is 6. 6 the whole square is 36. So 36 plus 1 minus of 5 is minus of 4. Minus of 4 the whole square is 16. So that is equal to 36 plus 16. Adding 36 with 16, we get the value of 52. So it is 52. Root of 52. So root of 52. This can be splitted as 4 into 13. Root of 4 gives 2. So 2 root 13. So 2 root 13 is the distance of AB. Similarly, we need to find the distance of BC. Distance of BC. So for calculating the distance of BC, we need to consider the point B and C. The point B here is 3, 1 and the point C is 0, 3. Let us assume these points as x1, y1 and x2, y2. So therefore, distance D is equal to what? D is equal to root of x2 minus of x1. That is 0 minus of 3 the whole square plus y2 minus of y1. 3 minus of 1 the whole square. That is equal to root of minus 3 the whole square is 9. So 9 plus 3 minus of 1 is 2. 2 the whole square is 4. That is equal to root of 9 plus 4 is 13. The root of 13 is the distance of BC. Thirdly, we need to find the distance of CD. For this, we need to consider the point C and D. C is 0, 3 and the point D is minus 1, minus of 4. Let us assume these points as x1, y1 and x2 and y2. So therefore, distance D is equal to what? D is equal to root of x2 minus of x1. That is minus 1 minus of 0 the whole square plus y2 minus of y1 the whole square. That is minus 4 minus of 3 the whole square. Which gives 1 square is 1 plus minus 7 the whole square is 49. So that is equal to root of 50. Root of 50 can be written as 25 into 2. 25, the square root gives 5. So 5 root 2 unit is the distance of CD. Next, we need to find the distance of AD. Distance of AD. For this, we need to consider the point A and D. The point A is minus 3, 5 and the point D is minus 1, minus of 4. Let us assume these points as x1, y1 and x2, y2. So therefore, distance is equal to root of x2 minus of x1. That is minus 1 plus 3 the whole square plus y2 minus of y1 is minus 4 minus of 5 the whole square. So that is equal to root of 2 square is 4. So 4 plus 9 square is 81. So that is equal to root of 85. So root of 85. Now we have found the sides of the quadrilateral. That is AB, BC, CD and DA. All the four sides we have found the distances. Next we need to calculate the distance of the diagonal. That is the length of the diagonal AC and BD. For this, we need to consider the point AC and BD. Distance of AC. So for calculating the distance of AC, we need to consider the point A, that is minus 3, 5 and the point C, which is 0, 3. So therefore, distance is equal to what? Distance is equal to root of 0 plus 3 the whole square plus 3 minus of 5 the whole square. So that is equal to root of 0 plus 3 the whole square is 3 square, which gives 9. So 9 plus minus 2 the whole square is 4. So that is equal to what? Root of 13. Here, if you see, that is BC plus AC is equal to AB. BC value is root of 13. BC plus AC. AC value is root of 13. Adding these two values, we will be getting 2 root 13, which is equal to AB. That is the distance of AB. This shows that these 3 points are collinear. They lie on the same line. So if it is the case, the figure formed here is not a quadrilateral and it is a triangle. Let us assume the point is D here. So if you join these figure, we will be getting a triangle and not a quadrilateral. So we can say that the following points represent vertices of triangle and not a quadrilateral. Vertices of a triangle and not a quadrilateral. It is not a four-sided figure, it is a three-sided figure. Exercise 7.1, problem number 6 of 3. Here they have given 4 different points. We need to check whether these 4 points form a quadrilateral. If so, what is the name of the quadrilateral? We need to justify our answer with proper reasons. Let us assume that these points as A, B, C and D, that is the vertices of the quadrilateral. Let A is equal to 4, 5, B is equal to 7, 6, C is equal to 4, 3 and D is equal to 1, 2. Represent vertices of a quadrilateral ABCD. Vertices of a quadrilateral ABCD. Next, we need to find the distance, that is the length of sides of the quadrilateral AB, BC, CD and AD. So for calculating the length, we are going to use the distance formula. That is D is equal to what? D is equal to x2 minus of x1 the whole square plus y2 minus of y1 the whole square units. First, we are going to calculate the distance of AB. Distance of AB. For calculating the distance of AB, we need to consider the point A and B, where A is 4, 5 and the point B is 7, 6. Let us assume this point as x1, y1 and x2, y2. So therefore D is equal to what? So therefore D is equal to root of x2 minus of x1. That is 7 minus of 4 the whole square plus y2 minus of y1. 6 minus of 5 the whole square. So that is equal to root of 7 minus of 4 is 3. 3 square is 9. So 9 plus 6 minus of 5 is 1. 1 the whole square is 1. That is equal to root of 10. Root of 10 units. Similarly, distance of BC. Distance of BC. For calculating the distance of BC, we need to consider the point B and C. The point B is 7, 6 and the point C is 4, 3. Let us assume these points as x1, y1 and x2, y2. So therefore, D is equal to what? D is equal to root of x2 minus of x1. That is 4 minus of 7 the whole square plus 3 minus of 6 the whole square. So that is equal to 4 minus of 7 is minus of 3. Minus of 3 the whole square is 9. 9 plus minus 3 the whole square is 9. So 9 plus 9 is root of 18. So root of 18. Third, we are going to calculate the distance of CD. Distance of CD. For this, take the point C and D. C here is 4, 3 and the point D is 1, 2. Let us assume these points as x1, y1 and x2, y2. So therefore, D is equal to what? D is equal to root of 1 minus of 4. 1 minus of 4 the whole square plus 2 minus of 3 the whole square. So that is equal to root of minus 3 the whole square is 9. 9 plus 2 minus of 3 is minus of 1. Minus of 1 the whole square is plus 1. So that is equal to root of 10. Similarly, we need to find the distance of AD. Distance of AD. For calculating the distance of AD, consider the point A and D. A is 4, 5 and the point D is 1, 2. Consider these points as x1, y1 and x2, y2. So therefore D is equal to what? D is equal to root of 1 minus of 4 the whole square plus 2 minus of 5 the whole square. So that is equal to minus 3 the whole square is 9. 9 plus minus 3 the whole square is 9. 9 plus 9 gives 18. So root of 18. Next, we need to find the length of the diagonals. That is distance of AC. Distance of AC. For this, we need to consider the point A and C. A is 4, 5 and the point C is 4, 3. Consider these points as x1, y1 and x2, y2. So therefore, distance D is equal to what? D is equal to root of 4 minus of 4. So 4 minus of 4 the whole square plus 3 minus of 5 the whole square. So that is equal to root of 0 square is 0 minus 2 the whole square is 4. So root 4 is 2. So 2 units. Finally, we are going to find the distance of BD. Distance of BD. For this, consider the point B and D. B is 7, 6 and the point D is 1, 2. Assume these points as x1, y1 and x2, y2. So therefore D is equal to what? Therefore D is equal to root of 1 minus of 7. 1 minus of 7 the whole square plus 2 minus of 6 the whole square. So that is equal to root of 6 square is 36 plus minus 4 the whole square is 16. So that is equal to root of 52. Root of 52 can be written as root of 4 into 13. Root of 4 gives 2. So 2 root 13 is the distance of diagonal BD. Here we have found the sides of the quadrilateral as well as the length of the diagonal of the quadrilateral. Using these details, if we construct a figure, we will be getting a figure similar to this. That is A, B, C, D. Represent a quadrilateral where the side length AB is equal to root of 10 units and CD is equal to root of 10 units. The length of BC is equal to root of 18 units and the side length AD is equal to root of 18 units. Here if you see, the opposite sides are equal in length and if you check the diagonal, they are not of equal length. That is, the diagonal AC is 2 units whereas the diagonal BD is 2 root 13 units. So, from this detail, we can confirm that the vertices, that is the given points, represents the parallelogram. We can write the reason as since the side length AB is equal to CD and EC is equal to AD and the diagonals AC is not equal to BD, we can confirm that the given points represent vertices of a parallelogram. Parallelogram. If you get the diagonal's length to be equal, then we can say it is a rectangle. Since they are different in length, they form a parallelogram.